Lecture 6 on multivariable calculus. So welcome back to lecture 6 on multivariable calculus. Recall in the previous lectures, actually we have extended the notion of differentiability for function from Rn to Rm. And in previous lecture, we gave some examples and calculate examples of the function from Rn to Rm, and we calculated their derivatives. Let us proceed and let me let us move forward. We begin with a proposition. So let U subset of Rn be open, and let A belongs to U. Let F is a function from U to Rn, and this thing G is a function from U to Rm. Besides that, both are differentiable. Then this function A plus G, the sum of this function A plus G from U to Rn is differentiable at A with derivative of A plus G prime at A is nothing but A prime of A plus G prime of A. Okay, so this is the if you look at the function of A plus G, and what is the definition of A plus G? So A plus G x by definition is nothing but fx plus gx. This is the definition of A plus G. Okay, so proof is pretty simple. You can try it in exercise, or you can just pause and try it on your own. But for completeness, I am giving the proof. So what is the meaning of f is differentiable at A? So so from hypothesis, this f is differentiable at A. We have this thing A plus G x is nothing but really since from hypothesis we have this, since f is differentiable at A, f of A plus h is nothing but f of A plus f prime of h plus little o of h. Okay, and since similarly we have this thing g of A plus h is equal to g of A plus g prime of h plus little o of h. Now if you will add this thing, if I will add I and 2i, so I plus 2i, then we'll give this thing, this f of A plus h plus g of A plus h. This is nothing but okay, so this is equal to, so I and plus 2i, I will give it maybe this thing, A plus g, A plus h. This is nothing but f A plus h plus g of A plus h. Now what is f of A plus h? F of A plus h is nothing but, this will be fa plus a prime of h and little o of h. So this f of A plus h is like this. Okay, and then it is plus this g of A plus h. G of A plus h is this. So I will get what this is equal to G of A plus G prime of AH. It's a little lower H. Okay. Okay, so this will G of A plus is this thing. So if we will add this thing, and I will use this expression, this thing, that little O of H plus little O of H is again little O of H. If I can add this, if you use this thing, so you will get F of A plus G of A. This is really A plus G plus F prime A plus G prime of A H plus little O. Call this as 3. Okay. Hence from 3 you get this thing. From 3 we have this thing. A plus G A plus H is nothing but F of A plus G A plus A prime of A plus G prime of A H plus little O of H. I'm calling this as IB. Oh, okay. So from above it follows that. Let's clear that. This thing. A plus G is differentiable at A and A plus G prime of A is equal to really F prime A plus G prime of A. Okay. So this is the thing which I wanted to prove. Now I want to prove the composition rule or chain rule. So okay, so so let U is a subset of Rn. U is a subset of Rn, say. Okay. Now this, suppose F is a mapping from U to Rn, and G B is open. B is an open subset of Rm, and G is a mapping from B to. Okay, so whenever this composition makes sense, okay, suppose this composition makes sense, that means if Fu, suppose Fu is contained inside B, that means this composition makes sense. So if you look at this thing, and this composition, U going to F of U, this is F, and G, if F of U is contained inside B, then this composition makes sense. Suppose A belongs to U, that means that will imply that F of A belongs to this B. Okay. Suppose F is differentiable at U, so this is open. This is an open. U is an open set. U is an open set, and B is similarly open set. B is an open set. Okay. Suppose this F is differentiable at A, so that means F prime of A is a mapping from Rn to Rm. Okay. Now similarly, G of F prime of A, G prime of F of A is a mapping from Rm to Rk. Okay. Now the composition rule say that. So we'll show. So it is chain rule. Chain rule says that this composition F G composition F prime of A is nothing but this is nothing but what G prime of F A into F prime of A. Okay, so this is what we want to prove. This is the composition G prime of composition F prime of A. Okay. Let us write that in a statement theorem. Okay. Let U subset of Rn be an open set. OS stands for open set. OS stands for open set containing A. So let F from U to Rm be differentiable. Dif means differentiable at A. Let B be an open set containing F of U. Let G from B to Rk be differentiable at F of A. So then it shows that then this composition G composition F of A, G composition F from U to Rk is differentiable at A with this thing G composition F prime of A is really G of F prime of A composition F prime of A. So theorem, let U subset Rn be an open set containing A, and let F is a function from U to Rm be differentiable at A. Let B be an open set containing F of U, and let G is a function from B to Rk be differentiable at F of A. Then G composition of F from U to Rk is differentiable at A. With G composition F prime of A is equal to G of F prime A composition F prime of A. Okay. So this is the thing. Okay. So proof is pretty simple. Okay. So what we want to prove this thing? We want to prove that. Okay. So let us say. So let B is equal to really F of A. Okay. So what is our goal? Our goal is to show. Goal. Okay. Is to show that this thing, if you look at G composition, so goal is to show that what G composition F prime of A is equal to G of F prime A composition F prime A. So goal is to show that this thing. So you want to show that G composition of A plus H is nothing but G composition F of A plus what? So this thing G of F prime of A, okay, composition F prime of A H plus little o of H. Yeah. So this is same thing as G of F of A. So this is we want to show that G of B sorry, I have written G of G prime of F. So I did a typo. There was typo errors. So our goal is to show this thing. So G of B, okay, plus g prime of b, okay, plus g prime of b plus into composition a prime of a prime applied on a g prime way. So this, if you, we can show this, this is done. Okay, proof is clear. If I can show that this is done. Okay, so what is given? So we have this condition that from hypothesis we have this thing. Hypothesis we have this thing, f is differentiable at a, okay. From hypothesis we have this thing that g of f is differentiable at a, so that means f of a plus h is equal to really f of a plus a prime of a h plus little over h. Okay, now when h is sufficiently small, this thing is valid. Okay, okay. So the thing is, okay, so this was and there is a this is given, but the thing is, when I told you that whenever you want to prove some result, don't use little o notation in the beginning, that will create confusion. So instead of OH, I will write this little of UH. And what is the condition of UH? This UH has this condition, norm UH by norm of H. This is this is the condition on UH is this thing. Limit h tends to 0, norm of UH by norm of H is equal to 0. Okay, this is condition 1. This is condition. So this is the F is differentiable. Okay. Now what is the condition on, we have another hypothesis that G is differentiable at f of a, but f of a we have assumed B. Okay, so G, since G is differentiable at a, since G is differentiable at B, we have this thing, G of B plus K is equal to really GB plus G prime B into K plus B of K. What is the condition on K? B limit K tends to 0, norm of Vk by K, this is 0. Okay, this is clear. Okay, now okay, so now what happens, actually K is an element of Rm by definition. This G is defined on a subset of B, and B is a subset of B is a subset of this Rm. B in open set, B in, let us write B in open set in Rm containing it. So okay, so this is the thing. Okay, now now our goal is to show that G composition f of A plus H is this thing. Okay, now let us begin that. So G of okay, so the thing is, I have to utilize this condition. I have to utilize this condition G of f of A plus H. Okay, so I have to prove this thing, G of F convolution H, G of B plus G prime B f of prime of A H plus little H. Okay, so this okay, so let I define this, let of K of H. Okay, this is really f of A plus H. So let Let I have f of let k of h, let it really f of a plus h minus f of a. Okay. So this k of h is really f of a plus h minus f of a. And this is same thing at what? The k of h is nothing but, if you look at I, this is nothing but f prime of h plus uh. A prime a applied on h plus u of h. Yeah. Okay. Now this thing now. Okay. So this then okay. So what I am to show? G composition f a plus h, right? G composition f a plus h. So this is same thing as G of f of a plus h. Okay. Okay. Now observe that since f is continuous at a, since f is continuous at a, this will imply that limit h tends to 0, kh is equal to 0. Because we know that if f is differentiable at a, then it is continuous at a. So that will give you. Okay. So g of f plus h, I can, so this is really, so f plus a plus h is nothing but f of a plus k of h. Okay. Okay. See, the thing is, I should tell you one thing, that this is valid. This writing f of a plus h is equal to f of a plus f prime of h plus uh. This is valid in a small neighborhood of h. Okay. And similarly, this is valid in a small neighborhood of k. Whenever k is normal, k is some very small. Okay. And this thing f of a plus k, since kh is very small, because if f is continuous at a limit h tends to 0, kh is equal to 0. So since k is very small, then this thing, this I can utilize this thing. Okay. So I can write this as a 3. This is 3. This is 4. Yeah. Okay. So this is really nothing but g of b plus kh, and this is g of b plus kh is nothing but g of b plus g prime b into kh applied on kh plus little b of kh. Now g of b plus g prime b, what is kh? Kh is nothing but f prime of ah applied on h plus uh. Prime of a applied on h plus uh plus b of kh. So this is g of b plus g prime b, a prime of a applied on h plus g prime b uh applied on uh plus b of kh. Now look at this expression. So g of g composition f of a plus h, we have got this thing. Okay. And what is our goal? Our goal is to show gb plus g, this gb plus g of f, g composition f of a plus h. I have to show that gb plus g prime b into a prime of ah plus oh. So if you look at these two expressions, those two expressions very careful, this thing is there already. If I can show that this quantity, this whatever remaining, if I can show that this quantity, whatever remaining, is of little o of h, then I am done. Okay. So let us show that. If I am okay. So first, to show that g prime of b is lower h, I can take the limit s tends to 0, g prime b applied on UH norm by this little, this is limit s tends to 0. So I am applying this norm of a b, norm of a b is less than equal to norm a, and this is g prime of b. Okay. Okay, so I am applied this thing ah, norm of ah is less than equal to norm a into norm of h. If you apply that, so this is less than norm of uh by norm of h. Okay. Now this thing, norm of by norm h, this goes to 0. Other tends to 0. So this, okay, and g prime is so this is equal to 0. And this is follows from where? Follows from 2. Follows from 2. Okay. So one quantity is there. So this implies that g prime of b applied on u of h is equal to little o of h. Okay. Now this second thing. Okay. Okay. So second thing is I have to show that b of norm of kh is really 0. So what I have to show? I have to show that limit s tends to 0, b of kh b of, I have to show that b of kh is little o of h. So if I can, so what I have to show that I have to estimate this thing b kh by norm of kh. Okay. Okay. So as to understand first the idea, we will write the proof letter. So the thing is, I have some information about v. The norm limit k tends to 0, norm of k by norm of k is 0. Okay, I have this. I want to use this information IB. So what I do, I just divide by this bkh by norm of kh by norm of kh by norm of h. Okay. So the thing is, if limit h tends to 0, if limit h tends to 0, we know that kh goes to 0. So this norm of bkh by norm of kh, this will go to 0. So what I'm saying, if limit h tends to 0, kh goes to 0 by this thing, since f is continuous at a, then I know that this norm of bk by norm k, this goes to 0. From IV, this is clear that this is 0. Okay. If I can show that this norm of kh by norm of h is bounded, then I am done as h goes to 0 in the neighborhood of h. If I can show that this norm of kh by norm of h is bounded, then I am done. Okay, this is the idea. Okay. Now let us see first this. So what I have to show, this is bounded, right? Okay. So first I have to show that this normal kh by h. Okay. So what is normal for kh? I can call this as really IB. This is okay. B. Can I call this B? Okay. So from B it follows that this thing. What is that thing? This B norm of kh. If I will norm of kh is less than or equal to f prime of h plus u of h. This is less than or equal to f prime of norm of f prime a into norm of h plus norm of uh. and this norm of kh by h, this is less than equal to f prime of a, norm of f prime of a plus so as it goes to 0, this norm of uh by h, this goes to 0, this norm of kh by h is bounded. Okay, so this is not a problem at all, so this is bounded. So let us see iv a, let us write it actually. Let us write it vi. Okay, let's write it b double I. Okay, so this thing is bounded. Okay, so then in limitations k is good. However, there is a problem here, because the thing is I do not know whether kh is 0 or not. I do not know whether kh is 0 or not. So you may ask that how can I divide by kh? So there is a, there's a problem. Okay, if kh is not 0 in a neighborhood of x, then we are fine. But it may happen that this b of um, kh may be just. So this is a very minor problem. So what we have to do? We have to. Okay, so we have to, in order to, means there is only issue that this kh can be 0 to apply this argument. So we can fix this thing. So what you do actually, you can take this letter eta k is really, okay, this norm of vk by k. Then when this k is not equal to 0. Okay, and see the thing is it 0 is equal to really v0. See, okay, you define this eta k norm of vk by norm k when k not equal to 0. Now, okay, observe that this, if you put k is equal to 0 here, k is equal to 0 here, k is equal to 0 here, then this p0 is equal to 0, right? Okay. So define eta 0 is equal to 0. So if k not equal to 0, you define eta k is equal to norm of bk by norm k, and you observe that this b0 is equal to 0 because everything is 0 here. So they define eta 0 is equal to 0. So thus this thing happens. Thus this thing, we have this thing eta k thus we have this thing eta k into norm of k is really norm of beta bk. Okay, and that will also imply that this condition will imply that since norm of beta k by norm k is equal to 0, okay, this will imply that limit k tends to 0, eta k is really 0. Okay, this is from IB. So call this as VI, right? VI B double I. Okay. Okay. So that means, so what we have proved? Oh, B double I. Call this as B triple I. Good. Okay. call B triple I. Okay. So now, okay. So now let us complete the proof. Okay. Also, okay. So what I have to do this, I have to prove that B of little co-op. So our goal is to show that B of KH is little this. So B of KH by norm of H. So this is nothing but eta of KH, okay, into norm of KH by norm of H. Okay. So okay. And okay, and this norm of KH, this is less than equal to eta K of H into norm of KH by H. So this thing and this thing, norm of KH by H is less than norm of A prime of A norm plus norm of UH by norm of H. Okay, so so this thing, since okay, if H goes to 0, this eta K, if K goes to 0, then eta K is equal to 0. So clearly, okay, from star, okay, I can call this as IISc. Clearly, RH of star, RHS of IX goes to 0 as H goes to 0, because K, if K's limit H tends to 0, then Kh goes to 0, so eta Kh goes to 0. The prime is a, so what I'm saying, if H goes to 0, Kh goes to 0, and you know that eta K goes to 0 as K goes to 0, so this is 0, and a primary constant, if H goes to 0, norm of UH by H, this goes to 0. Hence we get this thing, limit H tends to 0, norm of B of Kh by norm of H, this is equal to 0. Okay. Thus we have B of KH is equal to little O of H. Okay, so now I am calling this as capital A, calling this as capital B. So from VI and capital A and capital B, from this VI and comma capital A and capital B, we get this thing. We get that what do we get? G composition of A plus H plus H is nothing but G of B plus G prime of B, A prime of H plus little O of H. So this is nothing but G of composition F of A plus G prime of F of A plus A prime of H plus little O of H. Hence, G composition f of A, G composition is differentiable at A belongs at A, and okay, so this is what we wanted to prove, right? This is what we wanted to prove, and this is differentiable at A, and this G composition f prime of A is equal to G prime of f of A in composition f prime of A. Okay, so this is clear. Okay, so this we have proved the composition rule. One application. Okay. One example I have to show. Recall that, okay, so example, let f from GL and R to M and R given by this thing that f of x is really x inverse. And similar G, which is a function from M and R to M and R. Okay. So this given by this thing, G of x is really x squared. So if you look at this thing, G composition of this GL and R to M and R. Okay. Will be given by this thing, G composition f of x is equal to really x to the power minus 2. So the thing is, if so, we want to really calculate the derivative of this composition G of composition f x is equal to x to the. Now, what is f prime of A at h? Okay, so this is so okay. So we want to calculate this G composition question. So what is the question here? So calculate the derivative of G composition of, okay, the derivative of map x going to really x to the power minus 2 from this thing GLNR to MNR. This is my question. Okay, so the thing is, we know, okay, so we know that G composition of f x is equal to x to the power minus 2, and we have calculated this. We have seen that shown that f prime of a h is equal to really minus of a inverse h a inverse. This is clear. Somewhere we have in this, we have seen that in the previous class. Oh, this is the thing. If this is the thing that f of x is really x inverse, and I have seen that f prime of a h is minus a inverse h inverse. Okay, okay. So the thing is, okay, so we have seen that. So we have seen that f prime of a h is nothing but minus of a inverse h inverse. Okay. Similarly, we have seen that G prime of say BH okay. So G prime of BH, this derivative Gx, the derivative of the map is equal to really HB plus BH. Okay. Now this a composition G, or G composition of a. So G composition A prime H, or A prime of A, H will be what? G prime of A, composition A prime of A, H. This is nothing but, so G prime of F of A. Okay, F of A is there. So what is A prime of H? This is the minus of A inverse H A inverse. Okay. So look at this thing. Look at this star. And this, look at this 2. So from 2, it is told that this G prime of F of H is nothing but F. This is really minus of A inverse H inverse into F of A plus F of A into minus of A inverse H inverse. Okay. So this is really nothing but minus of A inverse H inverse, and F of A is really A inverse plus F of A is A inverse to minus of A inverse H inverse. This is really minus of A inverse H e to the power minus 2 minus of e to the power minus 2 H inverse. Okay, so the thing is this is clear. So we have also we have seen that this thing that this we have seen, we have also seen that this in the previous class we have seen that this is the indeed the thing, the derivative of the map f(x) is equal to x to the power minus 2 is this thing t of h is given by this thing. Okay. So this is the same map I am getting. Okay. In a different way. So this is the thing. Now I want to give some definition. See, the thing is now I will define something. We will see that we'll study those things in great detail, but let me define the new definition. Okay. So let f is a function. Okay. Let u subset of Rn be open and a belongs to u. Okay. So the thing is, so let f is a function from u to R. F is a real valued function. You can, okay, so let V belongs to Rn. So we define, so dVFA has to be this thing, limit t tends to 0, f of a plus tb minus f of a by t. See, this f is a real valued function, so this is in particular, this is a real number. Okay, so this dBFA is called directional derivative of f, okay, with respect to So relation of A at A of f of the function f at the point A at A in the direction B. So we define the V f A is equal to limit t tends to 0 f of A plus dB minus f of A by t. So this dBFA is called directional derivative of A at A in the direction B. Okay. Okay. This is clear. Now, small exercise. So that this thing happens. DCBF A equal C into DVF A. This C belongs to real number. So the directional derivative in the direction CB is really is equal to C times DVFA C belongs to R. Okay. Okay. So because of remark, okay. So this is the thing. And another thing you can, okay, so this exercise has two parts. Two parts, so D0 FA is always 0. Okay. Because of this remark, because of this previous exercise, of this previous exercise, because this previous exercise, suffices to study DBFA for norm B is equal to 1. So if the thing is, you don't, for a given function, you do not need to study all the directional derivative. Instead, you can, if you are able to study the directional derivative of A in the direction B for unit for all the vectors B of unit norm, then you can turn. Okay, so this is the case now. Okay, so now, okay, we are in, you know that this standard basis, this, so let us call this a discussion, little discussion. Okay, so let this thing U1, E2, En be the standard orthonormal basis. Orthonormal basis of Rn. Okay. So okay, so DEI of FA, okay, will be donated. It will be denoted as DIFA or del by del xi of A at A. So what is EI? EI is the vector in Rn where ith coordinate is really 1 and all other coordinates are 0. So this EI is really 0, 0, 0, 0, 1. So this is ith coordinate. Okay. Okay. So this del f, okay, this DIFA or del FA is these are, so this is called this is called okay, so let us say this is so del f by del xi at A, or this DIFA is called ith partial derivative of f at A. Okay. Now, if you look at this function x going into this thing, f of this thing a1, a2, a2. See, the thing is, if what I'm saying that you evaluate the so the thing is, if you look at this function gx, okay, look at this function x going to f of a1, a2, comma, comma, dot, 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 dot. In the ith coordinate, you keep only one variable xi, and remaining coordinates you fix the coordinates of a. You look at this function f of. So if you look at gx is really what that is gx. If you look at this f of a1, a2, xi, and other coordinates, you really fix the coordinate of a. Then this, so observe, if you look at this del g by del xi at the point ai is nothing but this thing del f. If you observe that this thing del g, sorry, del f by del xia is this is nothing but dg by dxi at the point ai. This is very pretty tool. So what I'm saying that difa by the notation difa, this means that ith partial derivative of at a, and this is nothing but this DEIFA, directional derivative of f in the direction ei. Okay, so now let us prove a proposition. So let A belongs to U and U subset of Rn be open. Let A from U to Rm okay, so I just okay. So I just wanted to I just forgot to introduce one notation. Maybe okay. Okay, so let us prove this proposition that then that f from U to Rm be differentiable at A. Then if you look at this thing, okay, so then this proposition says that del f, okay, differentiable at A, and suppose this thing happens. Suppose this fx is really f1x, f2x, fmx, okay? And this is x belongs to U. So that is, this fi is are really coordinate functions of f. These are really what? Coordinate functions of s. Okay, so then this proposition says that then this thing del fi by del xj at A exist for 1 less than equal to I, comma j, okay, 1 less than equal to I less than equal to m, and this j is equal to 1 to n. Okay. Now the thing is, since a prime A is a linear map from Rn to Rm, so a prime A is a linear map from uh, Rn to Rm, right? So it has a matrix representation. Okay. So with respect to standard basis, standard orthogonal basis. Okay. Then this a prime A, if you look at this thing, okay. So this matrix representation of a prime A into the standard base is nothing but what? This is a really M cross N matrix. Okay. You look at the first thing, so this will be first column will be what? Del F1 by del X1 A. Okay. Then okay. Now del F1 by del X1 A. And so this will be del F1 by del X1 A, then del F2 A. No, sorry, sir. So what I'm saying, so a prime A has a matrix dependent with this standard B. So this will be what? This will be del F1 by del X1. Okay. A. Then first column will be del F2A by del X1A. Similarly, del FMA by del XMA. So similarly, this is B, but del F2A by del X1A. Similar second column del F2 by del X2A, like this. Del FM by del X2. Okay. Similarly, this is del FMA by del FM by A by del X1A, del FM by del X2A, like this. Del FM by del X. Sorry, del XN. No, this is del X2A. I am confusing probably. Okay, so let us. What I'm saying is the following. I'm saying that this F prime A has a matrix representation. If you look at this F prime A matrix representation with the standard basis, so you will get this del first thing, third column will be del F1 by del X1A, then del F2 by del X1A, del Fm by del X1A. This is really similar del F1A by del X2A, del F2A by del X2A. This is del F2 by del Fm by del X2A. So the thing is, okay, so similarly, last column will be what? Del F. Sorry, this is last, again I am confused. So del F1 A by del X1, del Xn A, similar del F1 by del Okay, del f2 del f m by so what that means a prime of a matrix representation of a prime f is nothing but del ith del fi by del xj. So one less than or equal to m and j is equal to 1. Okay, okay. So okay, so let us write. So then this proposition says that let del f5 del xj exist for 1 less than equal to I. Let e1 e2 en and this thing u1 u2 um be the standard orthonormal basis for this thing Rn and Rm respectively, and let a prime a this thing denote the matrix representation of a prime a, which is a map from Rn to Rm with respect to the standard basis, with respect to the standard basis. So then this happen. Then a prime of a is nothing but del fi del xj at a. This is really 1 less than equal to I less than equal to m, j less than 1 less than n. Then so what does that mean? This is equivalent to the showing the part that a prime of a you applied if ej vector ej is nothing but summation I is equal to 1 to m del fi by del xj into ui. Okay, this is equivalent to proving that thing. Okay, so I hope the statement is clear. So let a belongs to u and u substitute Rn be open. That f is a function from u to Rn be differentiable at a. Suppose fx is equal to really f1x, comma f2x, fmx belongs to a. Then this partial derivative del fy partial derivative of the all coordinate function, partial derivative of coordinate function exists at a for 1 less than equal to I less than equal to m and 1 less than equal to j less than equal to n. That u1 e2 un and u1 e2 um be the standard orthonormal basis for Rn and Rm respectively. Let a prime a box denote the matrix representation of a prime of a from Rn to Rm with respect to standard basis. Then a prime of a matrix representation is del fi del xj. Okay, so this is equivalent to the proving that a prime of a is a is equal to really summation I is equal to 1 to m del fi del xj ui. Okay. Okay, so let us prove this thing. Proof is very simple. Okay, so what is given us? Okay, proof is very pretty simple. So the thing is, so since f is differentiable at a, so as f is differentiable at a, this thing happens that limit h tends to 0, a plus h minus f of a minus f prime of a applied on h norm by norm of h. This is 0, right? Okay. So this is 0. This means, okay. So I have to prove this thing that f prime of a is a applied on ej is something like this. Now, how do I do? The thing is, I can put h is equal to ej, but that will not help me. That because norm of ej is equal to 1. So what I will do in place of ej, I will put t ej and take limit t tends to 0. So this say that from this thing, limit t tends to 0, f of t ej norm minus f of a minus f prime of a t ej by norm of t ej. This is 0. Now this will give me limit t tends to 0. This is f prime a linear map and norm is an homogeneous function. This is really give you a plus a t ej norm of minus f of a minus t into f prime of a applied on ej by norm of t. This is 0. Then I can take t inside. Okay, if t inside, that will give you that limit t tends to 0, f of a plus t ej minus f of a by t minus f prime of a ej. This norm is 0. Now norm is a continuous function, so I can take now limit inside. This is limit tends to 0, f of t ej minus f of a by t is really f prime of minus f prime of a is equal to 0. So from above, what do we get? We get this thing. So f prime of a is equal to limit t tends to 0, f of a plus t ej minus f of a by t. So then that so that in particular that so that this limit exists. Limit at t tends to 0, f of a plus t ej minus f of a by t. So what is this, by the way? This is nothing but limit t tends to 0. This is really what f1 a plus t ej. So this is nothing but limit t tends to 0, f of f1 t of t ej minus f1a by t. Similarly, so this is, let us write. The right hand side is anything but limit t tends to 0, f1 of a plus t ej minus f1a by t, limit t tends to 0, f2 of a plus t ej got minus f2a by t dot last thing, limit t tends to 0, fma plus t ej minus fma by t. Okay, so that means this implies that these partial derivatives of coordinate functions are exist in the direction. So this will imply that this is nothing but, by definition, this is really del f1 by del xj. This is really nothing but del f2 by del xj. This is nothing but dot. This is so this del fm by del xj. So what I am getting this thing, a prime of a is nothing but what, I is equal to 1 to m del fy by del xj. Ui is the standard vector of Rm. So this is the thing we have to do. So that's so thus we have thus okay, this we have proved, and this is the proposition. Okay, so we have completed the proof. So the thing is, if f is differentiable at a, then partial derivatives of all the coordinate function exist at a. Okay, and we have this matrix representation. So the thing is, another definition. Okay, so another definition. So let f is a function from u to r, u subset of Rn be open, a belongs to u. So we define this vector, this grad of f at a is nothing but, so d1 fa, d2 fa, and this thing is d n fa. This is really nothing but del f by del x1. In another notation, this is a del f by del x2a and del f by del xn a. So this grad of a observe that this grad of f a. Okay, so this is belongs to where? This is an element of Rn. Okay. Now let us. So this ends here. So we will see this, the importance of this definition later. So now the suppose discussion. Suppose this thing happens. F is suppose F is U2 say Rm, U subset of Rn open, and this A belongs to U. Okay, because U is a function from U to Rm, U subset of Rn open, and U. Suppose F is differentiable at A. So what is a prime of A? A prime of A, matrix representation of a prime of A is nothing but, if you look at this del F1 by del X. Okay, so let us. So if you look at this matrix representation of prime A, this is nothing but del F1 by del X1 A. So this is really del F1 by del F2 by del X1 A. So this is really del Fn by del X1 A, del F1 by del X2 A, del F2 del del F2 by del X2 A. So del F M by del X2A. Similarly, this is so del F n by So del f1 by del x in A. So del f2 del x in del f m by del x. So this is, if you look at this thing, this is nothing but this thing. Grad of f1a, grad of f2a, grad of fma. So the thing is f prime a matrix representation of f prime a can be written as grad of f1a, grad of f2a, grad of fma. So this is clear. So the next class we will discuss in the next lecture we will discuss more about the directional derivative, and we'll see that if a function is differentiable at a, then directional derivative of f at a exists. And okay, so we will discuss. So if you like my video, you can share and share and give a like and subscribe, and let's share your friends to your friends. Okay, thank you. So we will meet in the next lecture.